Hello, my name is Yuvraj and we will study about the NDB and ADF today. So what is NDB? NDB is a ground-based transmitter which transmits vertically polarized radio wave, which is then received by the aircraft, which has the ADF, automatic direction finder in the aircraft, which gives the relative bearing from where the incoming signal is coming, which is the station. The NDB can be used for homing, holding, en route flying also. So let's read about the NDB. The frequency of the NDB is 190 to 450 kilohertz. ADF frequency is 190 to 1750 kilohertz. Wavelength is 600 meters, which is in hectometers. NDB works on the band of higher LF and lower MF. Higher LF means the frequency of the low. The band of the NDB is higher LF and lower MF, which means that the 30 kilohertz to 300 kilohertz comes under lower frequency, and it starts from 190 kilohertz, which comes on the higher side of the LF, and the 300 to 3000 kilohertz is the medium frequency band, and the 1750 comes in the lower side of the medium frequency band. So NDB is the ground-based transmitter, as I said, which is a vertical antenna. The NDB aerial length is half dipole aerial. It is called as the half dipole aerial because the length of the aerial is half the size of its wavelength. Principle is bearing by loop theory. We will study about the loop theory later on. The range of the NDB is 200 nautical mile by day and 70 nautical mile by night. But the accuracy is plus minus 5 degrees within beacon protected range. Only by day, protected range valid only during day, which means the NDB is unreliable at night. It is the night range doesn't comes under the protected range. The ADF is an airborne equipment and NDB is a ground-based transmitter. ADF is on the aircraft. It measures the direction of the incoming signal in relation to the nose of the aircraft. It gives the relative bearings. Let's read about the working of the NDB. So NDB is a ground-based transmitter which looks like this. It is placed on the ground vertically. It transmits the vertically polarized radio wave in all directions like a sphere around the antenna. It also called as the omnidirectional signal. There is an antenna below the fuselage of the aircraft which looks like this. Inside of this there is a loop like this. So before going ahead in the working, I want to tell you that there is an actual loop inside of that, which is called as the loop only, and there is a sense aerial which is placed with this loop. So when the plane of the loop is perpendicular to the direction of incoming signal, both sides of the loop receives the incoming radio wave equally, and the voltage difference between the two sides is zero, means no current flows inside of the loop. I will explain. Just suppose if this is the loop, which is on the aircraft, imagine you being the NDB ground station. The incoming signal comes to the loop when it is perpendicular to the incoming signal. This is the plane of the loop and this is the direction from which the incoming signal is coming. So when the angle is 90 degrees, the both side of the loop, let's say if this is B and this is A, so both A and B receives the radio wave equally, and there is zero voltage and no current is flowing inside of this loop, which is same when the signal is coming from my side. Look at this. From my side, if the signal is coming to this loop, it is still 90 degrees. The plane of the loop and the incoming signal, the angle between them is still 90 degrees. And current is not flowing inside of this loop because both the side of the loop receives the same energy of the radio wave. Alright, this is also called as the 180 degree ambiguity. Okay, we will talk about the 180 degree ambiguity later on. Now just imagine if the loop is like this and the incoming signal is coming from you towards this loop. This side of the loop is getting the maximum energy from the incoming signal, and this side of the loop receives no energy from the incoming signal. The voltage difference between the two sides of the loop is maximum, and maximum current starts to flow. And if I reverse it like this, then also it is same. This side of the loop is receiving the maximum energy from the radio wave, and this side of the loop receives very little energy from the radio wave. The voltage difference is maximum and current starts to flow, although the direction of the current flowing inside of the loop is changed when the signal is coming from my side and when the signal is coming from your side. So I can say that at two positions, this position and this position, the current flowing is maximum when the incoming signal is parallel to the plane of the loop. And when it is perpendicular, the current flowing inside of the loop is zero, right? So it has minimum current, which means it has two maxima and two minimas. Going forward, we'll read this. So when the incoming signal is perpendicular with the loop, it happens when the two directions same radio wave energy is received at both the sides of the loop equally. Thus no current flows in the loop, and this happens twice, which means it has two minimas. This is called as the 180 degree ambiguity. Okay. When the incoming signal is parallel with the loop, B side is receiving all the energy of the radio wave, and A side of the radio wave is receiving less radio wave, which creates the maximum voltage between the two. Thus maximum current flows in the loop, and this happens twice, which means it has two maximas. Having two maximas is not the problem, but having two minimas is the problem. So current flowing inside the loop is the function of the cosine of angle, which means the angle between the plane of the loop and the incoming signal. Which means when the angle between the plane of the loop and the incoming signal is 90 degrees, then cosine of 90 degrees is equal to 0. When the angle between the plane of the loop and the incoming signal is 0, then cosine of 0 is equal to 1, which means maximum current. If we talk about the polar diagram, now what is a polar diagram? A polar diagram is a graphical representation of the transmission and the reception property of a radio wave. Polar diagram of a loop is in the figure of 8, which has two null positions. Happens when the current is not flowing in the loop, and this is called as the 180 degree ambiguity. It happens when the signal is coming from the forward side and the aft side of the aircraft, not from the right and the left, because when the signal is coming from the right and the left side, it is maximum. Alright, so which means the ADF doesn't react when the signal is coming perpendicular to the loop. To remove this, an aerial is placed with the loop, which is along the normal axis of the aircraft, and it is not connected directly with the loop, but the loop signal and the sense aerial signal goes to the ADF and it removes the 180 degree ambiguity. Many people say that the sense aerial is placed within the loop, but it is not correct. The sense aerial is placed apart from the loop, but the resultant signal from the loop and the sense aerial goes to the ADF, and then it shows the corrected signal or the corrected relative pairing from where the signal is coming from. All right, it looks like this. The sense aerial does not give the direction, but it tells whether the signal is coming from the front or behind. How it does that? The polar diagram of the sense aerial, the shape of a circle, and combined polar diagram is in the shape of a cardioid. It comes often in the DGC exam as well. So if we talk about how it corrects the 180 degree ambiguity. When the signal is coming from the front side, the loop gives +1 and the sense aerial gives +0.5. So the resultant is +1.5. The sense aerial always senses whether the signal is coming or not. All right. And when the signal is coming from the back, it gives -1. Then the sense aerial gives +0.5. Resultant is -0.5. It means the 180 degree ambiguity is resolved. When the signal is coming from the right side, then the loop gives 0 readings and the sense aerial gives +5. And when the signal is coming from the left side, the loop gives 0 reading as well, and sense aerial gives +0.5. The resultant is +0.5 for both sides. So there is a doubt that when the signal is coming from the right side and the left side of the loop, readings are equal, then why it is not the 180 degree ambiguity? Because when the signal is coming from the right or the left side, it knows from which side the signal is coming from because of the direction of the current. But when signal is coming from the front or the back, the current is not even flowing. So how will it know the direction of the current? The original problem of the loop antenna was not left versus right. The problem was between the front and the back, which is why it is called as 180 degree ambiguity. Between the left and the right, the loop antenna already knows the axis on which the station lies because of the direction of the current flowing inside the loop. Then all this resultant signal goes to the ADF, which is the automatic direction finder, and it shows from which side the signal is coming from, which means it is showing from which side the station is. It gives the relative pairing, which is clockwise nose to home direction, measuring from the nose of the aircraft clockwise. So the coverage of NDB transmission depends upon the frequency and transmission power. Types of NDB, there are 3 types of NDB, which is the locator NDB, which is used with the ILS on the marker beacons. The coverage is 10 to 25 nautical mile. It is also often asked in the DTC exam. Second is the homing and the holding NDB, used as approach and holding. It is in the vicinity of an airfield. Rated coverage is 50 nautical mile. En route, long range NDB used for long range along the airway. Range is 200 nautical mile. So there are 2 types of signal, which is the NON A1A and NON A2A. NON A1A was the old one and the NON A2A is the newer one. Older NON A1A uses unmodulated interrupted wave. Range is actually more, which is 200 nautical mile. So the newer version is the NON A2A, which uses unmodulated plus amplitude modulated wave. Its range is 180 nautical mile. Decrease because of more static. So if we increase the modulation, whether it is the frequency or the amplitude modulation, the static will arise. Because of the static, the range of A2A decreases. And unmodulated interrupted signal means it is unmodulated radio wave. Interrupted means there are breaks in the radio wave. The range is 200 nautical mile. You can imagine if this is the radio wave, right? And we put breaks in them. then the total length from this side to this side will increase, right? Because it has few breaks in them. It means the interrupted wave. All right. Errors of NDB are there are many errors in the NDB, and you have to remember all the errors. So first is the precipitation static. Precipitation static happens because of the rainfall. Incoming signals may deplete like this. Because of the rainfall, incoming signals will deplete. All right, because of the precipitation static. Then there is the biggest error of NDB, which is the thunderstorm. So thunderstorm is the biggest error because of the lightning bolt and the static charge inside the thunderstorm. ADF needle is misguided and points towards the thunderstorm like this. So inside of the thunderstorm there are lightning bolts, and due to that lightning bolt, it radiates various types of energy, and the loop picks up these energy and points towards the direction of the thunderstorm. It is very dangerous because we always avoid flying inside the thunderstorm, but because of this error, it points the pilot directly towards the thunderstorm, which is very bad. So next error is the night effect. What happens during night is that the ionospheric layer shifts up, and NDB transmits the radio wave in all directions. So when it is transmitting, one goes in the surface wave and one goes in the sky wave. Due to the movement of the ionosphere, these two will combine and causes fading. Fading means a reception of radio wave from the same transmitter following two different paths, but it is the same radio. So it will also create the misguidance to the pilot. The maximum error is up to 30 degrees, which is maximum at dusk and dawn. Dusk means sunset time and dawn means sunrise time. And it can be felt at a distance greater than 60 nautical miles from the beacon. How to reduce this night effect? Use the NDB closer to the aircraft and use lower frequency because it increases the range. As you lower the frequency, the range increases. It is a property of the radio wave. Use beacon with greater power output. So as the ionospheric layer shifts up, the attenuation starts to increase, and with the increase of the power, the range can be increased. Next is the station interference. Now just imagine if you are flying between Delhi and Jaipur, right? Delhi has an NDB and Jaipur has an NDB station. When you are flying in between them, ADF gets the signal from the Jaipur NDB and the Delhi NDB both, which creates misguidance to the pilot and causes interference in the original signal. So this is called as the station interference. Occurs when two stations on same frequency. It has to be on the same frequency. ADF needle will lock in between as a resultant. All right. So now I'll show you the static interference like this. The ionospheric layer shifts up, and reflected sky wave will create interference with the surface wave or the ground wave, which causes fading. Then there is the mountain effect. When the incoming signal is reflected by the terrain, the ADF will point towards the signal, which will go directly to the mountain and not to the station, like this. The aircraft was coming towards the NDB. It is inside of this aircraft, the ADF is showing that ahead is the NDB station from the aircraft, but actual position is the mountain is ahead of the aircraft because the incoming signal is being reflected from the mountain. It is called as the mountain effect or the terrain effect due to the terrain on ground. Next is the quadrantal error. Occurs because of the metallic surface of the aircraft, which reflect and re-radiate signal. Maximum when signal coming at 45 degrees to the fuselage, and minimum when incoming signal is parallel with longitudinal axis and the lateral axis of the aircraft. Now, what is the longitudinal axis or the lateral axis of the aircraft? Just see, this is the aircraft. All right, this is the aircraft. So this is the longitudinal axis of the aircraft, and this is the lateral axis of the aircraft. The signal is, the quadrantal error is minimum when it is coming from this side, this side, this side, or this side, right? The quadrantal error is maximum at the quadrants, which means this side, this side, this side, or this side. I'll show you this. This is the quadrantal error. All right. You can see at 45 degrees maximum, 135 degrees maximum, 225 degrees maximum, 315 degrees maximum. These degrees are calculated from the nose of the aircraft, not from the heading of the aircraft. All right. So no error when signal is coming from the longitudinal axis and the lateral axis. Along the wing there is the lateral axis, and from the front and the back side there is the longitudinal axis of the aircraft. So next is the dip error. What is dip error? Dip error is caused by the banking of the aircraft, which causes the loop antenna to tilt away from its normal position. It's very simple. The dip error is the very simplest error. If this is the loop and this is the aircraft, so when the aircraft is in bank, the loop also bends, and because of this banking, the incoming signal voltage will change inside of this loop, which will give the error, which is called as the dip error in the NDB, or dip error in the ADF, we should say, because of the ADF is in the aircraft, right? Next is the coastal refraction. Due to the different radio energy absorption property of land and water, if radio wave does not leave the coast at 90 degrees, it bends towards medium of high density, that is land. So it is a property of a radio wave that it bends towards the high density medium, like this. The radio wave is bending towards the high density medium. In the upper aircraft, the radio wave is bending towards the high density medium, away from the normal. And in the lower aircraft as well, the signal is bending towards the high density medium, which is land. All right. And when the incoming signal is 90 degrees, there is no coastal refraction. All right. What is the solution? Use NDB signals 90 degrees to the coast. All right. What are the factors affecting range? NON A1A has more range, as we have seen, because of unmodulated signal and interrupted wave. Using interrupted wave, using breaks in the radio wave, the range is increased, which is 200 nautical mile. NON A2A, because of less static, right? So NON has more range than NON A2A because of less static. Then more range over C because of less topography. The meaning of topography means the terrain, the long grass, trees, buildings. So over C, it has more range. And the third one is the low frequency gives more range. We have studied this already in the basic properties of the radio wave. The lower frequency gives more range. All right, because it has higher wavelength. And transmission power, double the range, power has to be increased 4 times. The formula of the range is root over power in watts, and 2 root P over land, and 3 root P over C. So to double the range, mathematically, the power has to be increased 4 times. Lower the frequency, lower the attenuation. All right, higher the frequency, higher will be the attenuation. Why is that? So lower the frequency, lesser will be the attenuation. Why is that? Because it uses vertically polarized radio wave, which means that less radio wave is touching less earth, so less will be the attenuation. But if radio wave goes like this from the transmission, which means higher frequency radio wave, then it will touch more earth, which means more will be the attenuation. So lower the frequency, less will be the attenuation, greater the ground wave range. Because of the less attenuation, attenuation means the loss of power. So because of the less loss of power, the range is increased. Longer range over water because of less topography, and N1 A1A has longer range. We have studied this thing.
वीडियोस बनाने हैं, फिल्मोरा है ना।